So in determining compound probability, we need to know what compound probability is. Well, compound probability combines two or more events using the word and or the word or. Now, and represents an intersection, and or represents a union. So if I were going to explain that to you with a Venn diagram, we know a Venn diagram has overlapping. So let's say we've got people who like to play soccer and basketball. And we've got, 7 kids who only want to play soccer and not basketball. We've got 5 kids who like to play basketball and not soccer. But then let's say we've got 8 kids who like to play both. Well, the and is the intersection right here. Now the union, the or, would be all 20 of those kids. So this is or, and this is and, the intersection, just the 8 who will play both. And again, the or, soccer or basketball, both are great. So that's a union that combines everyone. It puts all of them together. So in our probability, that's what we're looking for. Are we looking for either or, it doesn't matter, or are we looking for it has to be both? So let's talk about, flipping a coin and rolling a die. That's a pretty common way of looking at compound probability. Don't get too excited by the word and here. That's not our compound probability yet. And when I say a die, obviously that is singular for dice. Dice is plural, and I'm talking about 6-sided die. So here are our 2 events. And you could do flip a coin twice, or flip 2 coins at the same time, or roll 2 dice at the same time, or roll 1 die twice, or 3 times, or 4 times, or 5 times. I mean, that would be 5 events if you were to roll it 5 times. But I'm going to make them different to make it hopefully more obvious. So first of all, what are the possible outcomes? Well, I like to make an array. You could make a tree diagram, whatever it is your preference. So I'm going to go with heads and tails, and across the top, 1, 2, 3, 4, 5, and 6. So I could get a heads and a 1, a heads and a 2, a heads and a 3. You see how this is going? So there are all the all the possible outcomes. And if they ask you to list it, I mean, that's really your list right there. You can see that we have 12 possible outcomes. Now when they ask about probability, then they will usually ask about, like, what is the probability of flipping a heads and rolling a 3. Well, this is intersection, meaning there's only one possible outcome. It's H3. So 1 out of 12. They could also ask, what is the probability of rolling an H or a 3? Well, these are all the H outcomes, or heads. I said H, but heads. And then all of the possibilities of rolling a 3 are these outcomes. Now you see we have a problem. Well, we don't really have a problem. We just need to be careful that there's this overlap right here. We don't want to double count it. So we've got 6 and 2 this way, but we don't want to double count this right here. So it's going to be 7 out of 12. Now something else we can do, and this might be helpful at some point, because not all things we can make a list for, is that whenever you are finding compound probability using the word and, you can take the individual probabilities and multiply them, meaning the probability of just getting a heads is 1 in 2. The probability of rolling a 3 is 1 in 6. With the word and, you can now multiply those probabilities. 1 times 1 is 1, 2 times 6 is 12. You just multiply the fractions, and you can see we got the same probability we got by making an array and counting it out. If there are ever any ways that you can double count those, then you have to subtract those out. You have to be careful with that. I don't have an example right now of that one. Maybe you could search the web for another one. With or, we do the same thing, but we do have an overlap, and so we would have to subtract that out. So heads again is 1/2, but with or we add. 3 is 1/6. So to get a common denominator, this is 3/6 plus 1/6. Now that would give us 4/6, which equals 8/12. But you have to remember that we have this one overlap, and so we have to subtract out that one overlap. Now that one overlap is 1 out of the 12 possibilities, so we need to subtract out 1/12, and you can see that 4/6 equals 8/12. So we're really doing 8/12 minus 1/12, which of course gives us our 7/12.